Hello everyone, welcome to the channel. Today we'll be doing questions of domain and range of function. A few simple questions on the same topic I've taken up in a previous video. You will find the link in the description below. Let's take up more questions on the same topic. So this is a quadratic and square root question. Let's factorize it. Our critical points are from here 3 and minus 3. You know you have to equate it to see when you get the critical points. Let's take a number bigger than 3, that is 4 say, and we find that this is negative, this is positive. The product will be negative, negative, and we know this is negative, positive and negative. We also decided that if it is of the form a minus x, it will always be negative, positive, negative in this order. And so, since it is square root, we like to have positive numbers and the domain becomes minus 3 to 3. See, minus 3 and 3 are allowed. If the function becomes 0, it is fine. If it would be 1 upon, we would have to avoid the extreme values. We'll see that in the next question. Okay, so over here it is minus 3 to 3. This is the domain. Let's go to the range. For range, we know we need to equate this to y and find x equal to, so that we can decide what values of y are allowed. Squaring with the sides, 9 minus y square is x square, and so the square root. Again we have, okay, here we can take plus minus, it's a quadratic value, so let's factorize it. It turns out to be similar to what we had in the domain. The only thing over here is we know that y value is going to be greater than or equal to 0. So again, let's plot the critical point. From here it is 3 and from the other factor it is minus 3. And since we have a minus y form negative, positive and negative. So y values from here can be minus 3 to 3. Combining these two results, we know that y should be non-negative and it should be between minus 3 and 3. So finally the range comes out to be only positive values in this interval, 0 to 3, including 0 and 3. So that is how we can find the domain and range for quadratic function. You can also do this by a shortcut method. So for shortcut method, we'll consider this as, say the function is root of a square minus x square. The domain will be minus a to a and the range will be 0 to a. So if you compare this, a square is 9 and so a is 3. The domain is minus 3 to 3 and the range is 0 to 3. So for objective questions, we can use the shortcut method. Now let's go to the next one. So now we are taking up this similar question, 1 upon it is. So here we know that those values which will make the denominator 0 will also not be allowed. And square root term should be positive. So factorizing like earlier, finding the critical point, which is minus 3 and 3 over here. Once again, since it is a minus x form, negative, positive and negative. You want, you can put a value and check. Now we want positive value, but not those values which make the denominator 0. So 3 minus x is 0, then x is 3. That means 3 is not allowed. And same way from here, minus 3 is not allowed. So now the domain is only open interval minus 3 to 3. So all values between minus 3 and 3. Okay, now for the range, let's equate it to y. We'll take reciprocal. Root of 9 minus x square is 1 upon y. Squaring both the sides. So 9 minus 1 upon y square is equal to x square. Let's take LCM. Okay, so what is x? Root of 9y square minus 1 upon y square. From here we already know y is positive. Keep that in mind. And let's factorize this because it is quadratic. Let us factorize. Now the critical points are y is equal to 1/3, minus 1/3 and 0. So let's plot them on the number line. It is now of the form y minus or variable minus the number. So it's going to start with positive, and negative. If you want, you can take a value bigger than 1, bigger than 1 by 3, say 1. So 3 minus 1 is positive and rest all are positive. So this term is positive. Okay, so now which values are allowed? We know those values which make this positive. We also know that y should be greater than 0 because it is in the denominator, y cannot be 0. So fine, positive values, minus 1 by 3. Yeah, we can include minus 1 by 3 to 0, union 1 by 3 to infinity. Is that good? Minus 1 by 3 to 0, 0 is not allowed, also in the denominator, and 1 by 3 to infinity. So for this also, we can write a shortcut method. Let's see what it is. So writing the function in general form, we have root of a square minus x square in the denominator. So the domain becomes minus a to a, and the range is minus 1 by a comma 0, 0 is not included, union 1 by a to infinity. Over to the next question. Fx is equal to root of x square minus 16. Once again, let's factorize this, which is x minus 4 and x plus 4. Critical points, x minus 4 equal to 0 will give 4, and this will give us minus 4. Now it is variable minus numbers, so start with plus on the right side, and we need to have non-negative values. So the domain is minus infinity to minus 4 and 4 to infinity, including both of this. So that's the domain. For h, we know we'll have to equate it to y, and y is greater than or equal to 0. Since its numerator value equal to 0 is allowed. Let's find x from here. So squaring of the sides, x square minus 16 is y square. X square is y square plus 16. So x is plus minus. Now all values of y are allowed. There is no such value which will make this square root term undefined. And from here we have greater than or equal to 0. So the range becomes 0 to infinity. So in this one, if you write the shortcut formula, it is domain, which is minus infinity to minus a, union a to infinity, and the range is 0 to infinity. You just need to locate the value of a. Like if it's a square is 16, a would be 4, a square is 81, a is 9, and whatever the value. Going up to the next question, it is 1 upon root of x square minus 81. So factorize it. Mark the critical points, minus 9 and 9, equating both of this to 0. So since it is variable minus number, it is positive, negative and positive. We are looking for positive values, and also this term should not be 0. Where is it going to become 0? At the critical point. So we need to remove them. And so in this case, the domain becomes minus infinity to minus 9, not including minus 9, union 9 to infinity. whichever values are positive and whichever doesn't make it 0 since it is in the denominator. Okay, now going to the range. Let's equate it to y and squaring both the sides so that we don't have root. Also we can take reciprocal. X square minus 81 is 1 upon y square. X square is 1 upon y square plus 81, or otherwise x square is 1 plus 81 y square upon y square. So what will be the value of x plus minus under root of this? So the only value which is not allowed here we see is that y whenever y is 0. So y not equal to 0, and from here we know that y is greater than 0. So that's fine. It becomes 0 to, it becomes open interval 0 to infinity. This is the range of the function. Since 0 is not allowed, open bracket. So let's write this down also in the general form. So from the previous question, we can infer that the domain is minus infinity to minus a union a to infinity. Just find the value of a and put it here, and the range will be open interval 0 infinity. For questions like this, where only domain is asked, we have to see that the denominator should not be 0. So let's factorize this and find the critical points. So it is obviously plus 3x minus 2x, that's splitting the middle term. And we have the factors as x plus 3 and x minus 2. That means all real numbers are allowed except when x plus 3 is 0, that is minus 3, and when x minus 2 is 0, that is 2. So finding the domain for questions where you have rational functions, you just look for the denominator, factorize it, find the critical points and remove that from real numbers. That will be the domain. So in this function, again, we have a rational function. Let's factorize the denominator. And we observe that this would not be possible by splitting the middle term. So let's go with discriminant method and find x. So obviously we know over here a is coefficient of x square 1, b is coefficient of x minus 8 and c is 4. So let's put these values here. b is minus 8, minus 8 square, a is 1 and c is 4. Simplify this. On simplification, we will get the value of x as 4 plus minus 2 root 3. These values are going to make the denominator 0. So remove it from real numbers. That is the domain. So whichever terms are making the denominator 0, you need to remove that for rational functions. So here we have the next function, root of x plus modulus x. Now since we have modulus x, let's redefine this function and see what it becomes. By redefining, we mean put x, modulus x as minus x and modulus x as plus x. So this is root of 0, 0 for less than 0 and root of 2x for x greater than or equal to 0. Look for which values it is defined. This is good, fine, f(x) is equal to 0 for less than 0. And over here, since we are taking non-negative x values, under root is defined, and so the domain is all real numbers. Now what would be the range? We see for negative numbers, the answer is going to come 0, and for non-negative, it is positive square root. So the range will be only non-negative numbers. You put non-negative values for x and your answer comes out to be non-negative. It is positive square root. and over here it is 0. For all negative numbers will become 0, and for rest it is 0 to infinity. So the range is 0 infinity. If the same thing would be 1 upon, then the value cannot be 0. You would redefine it in a similar way. Now this would become undefined because it is going to be 1 by 0. So this is not allowed. Means all numbers smaller than 0 are not allowed. Also equal to 0 will not be allowed because then again it is going to be 1 upon 0. So the domain here would be only 0 to infinity. So finally our fx will only be 1 upon root of 2x for x greater than 0. Negative value is not allowed, equal to 0 not allowed. So domain is 0, infinity. Now let's find the range. To find range, as usual, let's equate it to y, and we know y is going to be greater than 0. Squaring with the side and finding x from here. X is 1 upon 2y square. Y is non-zero, so this is going to be defined. Also it is positive, so the range is 0 to infinity. Both domain and range are the same. So as you must have noticed, domain and range is a very vast topic. The more questions you practice on this topic, the more learning you will develop. Wherever possible, for multiple choice questions, use the shortcut tricks. Before you leave, hit the bell icon, like and share the video. Thank you.